Alright, so in this video we are going to be solving questions of the topic APGP, and as I've been doing in the past, so what I've done is I have in this PDF I have attached my notes and a couple of example questions. So these are basically notes from the online sessions, from my online classes, so you can make use of this and you'll find all the important formulas. Although formulas is something you don't really have to revise, I should mention that you will be given the formulas at the very beginning of the question paper, so don't waste too much time revising memorizing the formulas. But yeah, what you do need to learn is how and when to apply which formula. Okay, so this topic, as I mentioned, or I don't know if I did, this was added in May-June 2020. So we don't have a lot of questions of this topic, so I'm going to be solving like 2-3 questions in this video. But if you guys do want some more practice material, you can always reach out to me on Instagram. I'll leave a link below. And if you're new to this channel and you haven't subscribed yet, so make sure that you subscribe. I will be posting more videos for AD Maths, and I will also be posting videos for AS level maths, so you guys can benefit from it. Anyway, so it says an arithmetic progression has a second term of -14 and sum to 21 terms of 84. Find the first term and the 21st term of this progression. By the way, I should also mention that I have covered this topic concept by concept from scratch in a separate playlist, so I'll leave a link to that playlist also in this video, and then you guys can watch that also. Anyway, so let's get to work. So you're dealing with an arithmetic progression. What I would suggest is that as soon as you read the question, so the fact that we're dealing with an arithmetic progression is something that's very important. We're going to decide which formula to use depending on the progression that we're dealing with. So make sure that you highlight that or underline whatever. So you're given the second term, and you're given the sum of 21 terms to be 84. Find this the first term and the 21st term of this progression. Okay then. So basically, if you're given the second term, yeah, so second term means that T2, so that's equal to -14, and you're given the sum to 21 terms, so that means S21 is equals to, whoops, sorry, not 81, it's 84. Okay. Now one thing's for sure is that we're going to be using the sum formula, and we're going to be using the nth term or the general term formula. So if I want the general term, the formula to calculate the general term, like I said, it's given to you in the question paper. It's a plus n minus 1 into d, where a is the first term, n is the term that you want, and d is the common difference. So over here, we don't know what the first term is, so I'll let that to be a. We know that we're talking about the second term, so that means n is going to be equal to 2. We don't know what the common difference is, so that's fine, but we do know that this term is actually equal to -14. So that means we're looking at a plus d equals to -14. So in this equation, we have two unknowns. So clearly this equation is not enough for us in order to figure out the value of these two unknowns. So we need another equation, and the question has been kind enough to provide us with the information with the help of which we can come up with another equation. And that information is the sum of 21 terms. So as you know, you have two formulas for calculating the sum. One is n upon 2 into a plus l. So we're not going to be using that formula, because in this you need to have the first and the last term. What we will use, however, is this formula, which is n upon 2 into 2a plus n minus 1 times d. Okay. And the reason behind using this formula is because, like I said, we don't have we need an equation that is in terms of a and d, so that we can use that equation with this equation and find out the value of a and d. Okay, now I'm just going to plug in the values. So n is 21 because we have 21 terms, and we don't know a, so we'll leave that to be as it is. N is again 21, so 21 minus 1 times the common difference, and this sum, according to the question, is equals to 84. So I'm going to write this nicely. I'm going to simplify this. So first things first, 2 is going to get multiplied by 84. So we're looking at 84 times 2, and then I'm going to divide this by 21. So I'm looking at 8. So the two equations that we have are 2a plus 20d is equals to 8. Okay, here's the second equation. So, well, you have a lot of options. I think I'm going to go with elimination. So what I'll do is, I'll bring this equation over here, and I'm going to multiply the first equation by -2 and write it just under the second equation. So we're looking at -2a minus 2d, which is equal to positive 28. All right, let me just make sure I haven't done anything wrong. Yep, looks good. So if I add the two equations, a and a get eliminated. That's the objective. 20d minus 2d is going to be 18d, and then we're looking at 28 plus 8, which is 36. So that means we have the common difference. So 36 divided by 18 is equals to 2. Now, we had to find the first term and the 21st term of this progression. So we've just found the common difference. We still need to find the first term. So I'm going to go back to the simpler equation, which was a plus d equals to -14. I'm going to replace d with 2, set it equal to minus 14. And now we have the first term, which is minus 14 minus 2, so that's minus 16. So now I have a. Now all I got to do is find the 21st term, which is basically the last term of this progression. So all I got to do is I'm going to come back to this formula, S21 equals to 84, and this time I'm going to be using this formula so that I get the last term right away. Although what you can do is, you can use the common difference and you can use the first term and just figure out the 21st term. You can totally do that and you will get the right answer. So 84 is equals to 21 upon 2, and the first term is minus 16, and then the last term, which is L. So 84 times 2 divided by 21 is 8, so 8 is equals to minus 16 plus L, and then making L the subject, so we're looking at 16 plus 8, so that's equal to 24. So that means the last term is equal to 24, and there you go. We figured out the two things that we were supposed to find. That means we're done with part A, and we get 5 marks for that. So not a bad deal. Anyway, so now we come to part B of the same question, which says a geometric progression has second term of 27p square and a fifth term of p to the power 5. The common ratio r is such that it is greater than 0 and less than 1. So there's probably a reason why it's given us, why it's telling us that the common ratio is between 0 and 1. We'll find that out later on as we go along. And then it says find r in terms of p. Okay, so you have the second term and you have the fifth term. So first things first is that the fact that you're given that this is a geometric progression, so you should instantly highlight or underline the word geometric progression so that you know exactly what formula that you have to use. And since this is a geometric progression, again, do not waste time memorizing the formula. This is the formula that we're going to be using, a r raised to the power n minus 1, at least in this part. Okay, so you're given the second term. Now second term means that t is going to be equal to 2. So this that you're looking at, 27p squared, this is what t2 is equals to. And the fifth term is p to the power 5, so that's what t5 is equals to. Okay, now if the second term is equals to p square, that means a r raised to the power 2 minus 1, so we'll just write it as 1, is equals to 27p squared. And then another equation would be that fifth term, so that means a r raised to the power 5 minus 1, so that's 4, that's equal to p to the power 5. Now let's see what you're supposed to do. You're supposed to find r in terms of p. So what I'm going to do is I'm going to use any one of the two equations and make a the subject. So if I use the first equation and make a the subject, that means I'm looking at 27p square upon r, and then I'm going to take this value of a and plug it in equation number 2. So that means I'm looking at 27p squared upon r is equals to p to the power 5. Okay, don't forget that you already have an r to the power 4 here, which I just forgot to write. Okay, now there's a lot of simplification that needs to be done before we can find out what r is equals to, so let's do that. So you have r power 4 and r to the power 1, sorry, it's not square, it's r to the power 1. That means you're looking at 27p squared. So the r from the denominator will cancel out and will reduce the power of 4 by 1. So we're looking at r cubed is equals to p to the power 5. Okay, now let's make r the subject. When you do that, so you'll end up making r cubed the subject. That means you're looking at p to the power 5. And then this you'll divide by 27p squared. Now since you have the same base, p5 and p squared, that means you can reduce the power by 1. So you're looking at r cube is equals to p cube upon 27. Now I still don't have the what r is equals to. That means you need to take the cube root on both sides. Now when you do that, you get r is equals to p, and the cube root of 27 is 3. So now you have what r is equals to. It's equal to p upon 3. Then it says, hence find in terms of p the sum to infinity of the progression. Now sum to infinity is basically equal to a over 1 minus r, and you can only find the sum to infinity for as long as r is greater than minus 1 and less than 1. And that's the reason why the question told us that the common ratio is between 0 and 1. That means the sum to infinity of this progression can and will exist. Okay, now a is equals to 27p squared upon r. You can see over here that this is what a is equals to. Now that we know what r is equals to, I'm going to replace it by p upon 3, and then this is basically divided by, the reason why I'm writing it separately is because we're going to end up with a fraction in the denominator also, 1 minus r, that means 1 minus p upon 3, and I'll just make a bracket here. Okay, now this is the part where I start simplifying. So 27p squared divided by p upon 3, so I'll do it over here. So you're looking at 27p squared divided by p upon 3, that means you're looking at 27p squared into 3 upon p. So 27 times 3, let's see what is that equal to, 81. So that means you're looking at, and p squared upon p is basically p. So you're basically dealing with 81p divided by, now if you take the LCM here, so you'll have 3 as your LCM and then 3 minus p. Yeah, this is what you're going to end up with. And then once you change the division sign to multiplication, so that means you're dealing with 81p times 3 over 3 minus p. Yeah, so you can leave it as it is, or if you want, you can multiply this, and 81 times 3 is 243p over 3 minus p, and this is what your sum to infinity is. Then it says, given that the sum to infinity is 81, find the value of p. So all you got to do is you got to equate the sum to infinity, which is 243p upon 3 minus p equal to 81, and then cross multiply. So you're dealing with 243p equals to 81 times 3, which is also 243, minus 81p. Okay, minus 81p. Now let's take 81p over to the other side. So 243 plus 81 is equal to 324. So 324p is equals to 243. P is equals to 243 divided by 324. That means p is equals to 3 upon 4. And what exactly we're supposed to find? We're supposed to find the value of p. We just did that, and this is the correct answer. So I hope you've understood this question. Now let's move on and do another question. And I have this question here. This is, I should mention, from May June 2020, paper 2, variant 2. And the question that we just solved, by the way, I don't know if I mentioned it. This is also from May June 2020, paper 1, variant 1. Okay, so it says here the first 5 terms of a sequence. So we don't know what kind of sequence we're dealing with. Could be a geometric sequence, could be an arithmetic sequence also, are given below, and we're supposed to find the 20th term of the sequence. So let's quickly find out the kind of sequence that we're dealing with. So in this sequence, you can see that you have a plus, a positive value, and then a negative value, and then a positive value, and then a negative value, and then a positive value. So if this were an arithmetic sequence, once the value was positive, it would have been positive consistently, because that's what you do in an arithmetic sequence. You consistently keep on adding a certain value in order to get to the next term, or you consistently keep on subtracting a certain value. So in an arithmetic sequence, the signs aren't alternate, but in a geometric sequence, the sign can be alternate, because it could mean that you're multiplying every single term by a negative value in order to get to the next term. So that's what this deal is over here. Now to further clarify, to further make sure what kind of sequence we're dealing with, what we can do is we can take a preceding term, which is, let's say, we can take any two terms. So let's say minus 2 divided by the preceding term. So that's equal to, well, we'll simplify this later. And let's see if this is equal to this. 1 upon minus 2. So they both are equal. Minus 1 upon 2 is in fact equal to minus 1 upon 2. That means we have a common ratio here, which means that we're dealing with a geometric sequence. Now we know that the common ratio is equal to minus 1 upon 2. We can see that the first term is equal to 4. Now if you want the 20th term, so here's what you're going to do. T20 is going to be equal to 4, or which is minus 1 upon 2 raised to the power of 20 minus 1. That means raised to the power of 19. So let's find this out. So we're looking at, make sure that you don't make a sign error, or else you'll end up getting the whole question wrong. So minus 1 upon 2, make sure to put a minus sign inside the bracket, to the power 19. So you're looking at, okay, then minus 1 upon 131,072. Yeah, and this makes sense since common ratio is minus half. That means the 20th term is going to be extremely small. Yeah. Explain why the sum to infinity exists for this sequence and find the value of the sum. So because the common ratio is minus 1 upon 2, and we'll say r is between minus 1 and 1, therefore sum to infinity exists. Okay, you have to be very specific and to the point, no messing around. And then you want to find the value of the sum. So sum to infinity, as we know, is equal to a over 1 minus r. So we can see that the first term is 4, 1 minus minus 1 upon 2. So let's see what the sum to infinity is. Okay, let me just draw this nicely. Sum to infinity. Yeah. So the sum to infinity is going to be equal to 4 over 1 minus 1 upon 2. So that means minus is going to be plus. And we're looking at 8 upon 3 as our final answer. Okay. Now this brings me to, in fact, no, wait, it's still the same question. Yeah. So it says the 10th term. Now we're dealing with an arithmetic progression, the 10th term of an arithmetic progression is 15 times the second term. The sum of the first 6 terms of the progression is 87. Find the common difference of the progression. So again, very similar to the first question that we did. So you're given the 10th term, that means T10, and you're also given is equals to 15 times the second term. So 15 times T2. So this is probably going to give me the first equation, and then it tells me that the sum of the first 6 terms of the progression is 87, so S6 equals to 87. Now if you want the 10th term, so that means A plus 9D is equals to 15 times. You want the second term, so that's going to be A plus 2 minus 1 times D, so just A plus D. Okay, now don't forget to make a bracket here, so you're looking at A plus 9D is equals to 15A plus 15D, and you can probably see where we're going with this. So we get minus 14A, and then 9 minus 15 is minus 6, so minus 6D is equals to 0. It's always best to multiply both sides by minus, so that you have 14A plus 6D equals to 0. Although if you want, you can also divide it by 2. In fact, I think I am going to divide it by 2, both sides by 2. So you're looking at 7A plus 3D equals to 0. Okay. And then you're dealing with sum of the first 6 terms, which is equal to 87. So sum is equals to n upon 2 into 2A plus 6 minus 1. So that's going to be 5 times the common difference, which is equal to 87. N is going to be equal to 6, which I forgot to write. So there you go. So first thing I'm going to do is I'm going to take 87 multiplied by 2 and then divide by 6. So I'm looking at 29. So that means 2A plus 5D is equals to 29. And here's my second equation, and here's my first equation. Okay, so I am going to go with the method elimination. So if I want to do elimination, that means I'll have to multiply both by a certain value. So let's do that, nothing to worry about. Although you can do it in your calculator to save some time, but let's see. We'll end up practicing simultaneous equations also. So I'm going to multiply. So I've decided that I'm going to eliminate D. So if I want to eliminate D, that means I'm going to multiply the first equation by 3 and the second equation by 5. So if I multiply the first equation by 3, I'm looking at 6A plus 15D. In fact, I'm going to multiply the second equation by minus 5, just so you know, is equals to 29 times 3. So 29 times 3 is equals to 87. So that's my first equation. The second equation is going to be minus 35A plus, in fact, minus 15D is equals to 0. Okay, now 6 minus 35 is equals to 29. So minus 29A, sorry, not D, minus 29A. 15D minus 15D get eliminated. That was the objective, is equals to 87. So we're looking at 87 divided by minus 29. So A is equals to minus 3. And now that you have the first term, you can use it to find the common difference. And that's exactly what I plan to do. I should have eliminated A in the first place, but anyway. So 7 times minus 3 plus 3D equals to 0. That means we're looking at 3D is equals to 21, because that's what 7 times minus 3 is. It's going to be minus 21 once you take it over to the right hand side, sorry, it's going to be 21. And then the common difference equals to 7. Okay. Then it says for this progression, the nth term is 6990. Find the value of n. So there is a certain term which is equal to 6990, and our job is to find which term that is. So no big deal. So we're going to do A. So good thing we figured out A, in fact, we need it now, plus n minus 1 times D, which is 7, is equals to 6990. And you get 3 marks for this. Okay, that's pretty cool. So you're looking at n minus 1 times 7 is equals to 6993, because once you take minus 3 over to the right hand side, it gets added. And now you're looking at 6993 divided by 7. So n minus 1. Actually, there's no need to put a bracket anymore. So n minus 1 is equal to 999, which means n is equals to 1000. And there you go. That's the final answer. Now I'm going to do one more question for you guys, and this time I have a question which deals with a bit of trigonometry also. I hope I have it in this PDF. Yeah, okay. So this is a question that I want to solve for you guys, and this is from May-June 2021, paper 1, variant 2. Okay, yeah. So it says here, the first 3 terms of an arithmetic progression are minus 4, 8, and 20. Find the smallest number of terms for which the sum of this arithmetic progression is greater than 2000. Okay, so let's write down the first 3 terms that were given, minus 4, 8, and 20. Now with the help of these three terms, I can figure out the first term. Actually, I can see what the first term is. It's minus 4. I can figure out the common difference by taking the second term and from it subtracting the first term. So 8 minus minus 4 is going to be equal to 12. Or you can look at it this way, that you're consistently adding 12 in order to get to the next term. Okay. And then you want the smallest number of terms for which the sum of this arithmetic progression is greater than 2000. So what I'm going to do is, I'm going to find out the number of terms that I need in order to make sure that the sum is equal to 2000. Now let me explain something. Let's say the value of n that we obtain over here turns out to be 10. Hypothetically speaking, I don't know what the answer is. That means 10 terms sum up to 2000. So if I want the smallest number of terms for which the sum is greater than 2000, the answer is going to be 11. Let's say the answer to this turns out to be 5.6. Okay, again, hypothetically speaking. So at 5.6 terms, although that's not possible because terms should be integer, so that means 5.6 terms sum up to 2000. So the final answer is going to be 6. So that's what you got to keep in mind. So as far as the sum is concerned, the formula for calculating the sum is n upon 2 into 2a plus n minus 1 times d, and this is equal to 2000. Okay. Now we don't know n, so that's the only unknown in this equation. We know that a is minus 4, n minus 1 again, and then d is equals to 12 is equals to 2000. Okay, so once you take this 2 multiplied by 2000, so you end up with 4000. And then in the bracket you have minus 8 plus 12n minus 12, and you have an n sitting outside equal to 4000. So minus 8 minus 12 is going to be minus 20. So in fact, you know what? I'm going to bring this over here so that I have some space. So n times minus 20 plus 12n is equals to 4000. You can see that we're about to end up with a quadratic equation. So minus 20n plus 12n square. Let's shift 4000 over to the left hand side also, equals to 0. That means we're looking at 12n square minus 20n minus 4000 equals to 0. Okay. So just to save some time, I'm going to use the quadratic equation feature in the calculator to solve it. So 12 minus 20 and minus 4000. So I'm looking at two values. One is 19.109 and the other is minus 17.4. So we reject the minus value straight away because we're dealing with number of terms. They can't be negative. Now at 19.1, the sum is exactly equal to 2000. That means when n is equals to 20, the sum will be greater than 2000. And although it's going to be greater for 21, 22, 23, but since the question asked us for the smallest number of terms, so we'll settle for 20, and that's our final answer. Okay. Then it says, here's another part to it. The 7th and 9th terms of a geometric progression are 27 and 243. Find that given that the geometric progression has a positive common ratio, find the common ratio. Okay, so it says here positive, so that's important. Okay, so here's how we do this. So an easier way to do this question, in fact, I think I am going to opt for the easier way. So you're given the 7th term, you're not given the 8th term, but you're given the 9th term. Now, if the 7th term is 27, you know very well that in order to get to the next term in a geometric progression, you multiply it by the common ratio. So that means the 8th term is going to be 27r. And then in order to get to the 9th term from the 8th term, you're going to multiply by r again. So times r times r. That means it's going to be equal to 27r squared. And the 9th term is basically equal to 243. So that's what I'm going to do. I'm just going to equate the two. 27r squared equals to 243. That means r squared is equals to, I think, 9. Let me double check. 243 divided by 27. Yep, it's equal to 9. Or although it's going to be equal to plus minus 3, but we'll just settle for plus 3 because the question says that it has a positive common ratio. And then it says the 30th term giving an answer as a power of 3. Okay, so that means we are going to need the first term. Yep, we're going to need the first term also. Okay, so let's find out the first term. So, let's make use of the 7th term. So a, or raised to the power 7 minus 1, so that's 6, is equals to 27. So we know the common ratio. That means a, 3 raised to the power 6 is equals to 27. So a is equals to 27 divided by 3 raised to the power 6. So we're looking at 1 upon 27. Then it says find the 30th term. Now in order to find the 30th term, we're basically looking for a or raised to the power 30 minus 1. That means 29. Now, we don't just have to find the 30th term, we also have to do it as a power of 3. Now, let's see if you can see where this is going. So ours is 3. That means we're going to raise 3 to the power of 29. Now, if you do this in your calculator, you'll notice something strange. So 3 to the power 39 is an answer that's in standard form. And once you divide by 7, it's still an answer that's in standard form. Okay, your calculator doesn't have the capacity to work it out. That means now this is a point where you need to think outside the box. And 27 is not an ordinary number. It's a power of 3. And 3 raised to the power 29 is already written as a power of 3. So that's what we're going to do. We're going to rewrite 27 as a power of 3 so that we can work out our final answer as a power of 3. So 29 minus 3 is going to be 3 raised to the power of 26. And that's our final answer. Now here's part C, which I found to be pretty cool when I first saw it. It says explain why the geometric progression 1 and then sine theta and then sine square theta, so on and so forth, for theta is between minus pi by 2 and pi by 2, is in radians, has a sum to infinity. Now remember, the one condition that our progression should meet to have a sum to infinity is that the common ratio should be between minus 1 and 1. Can't be equal to minus 1, it can't be equal to 1. So if I want the common ratio, I'll just take the second term and divide by the first term, or I'll take the third term, which is sine square theta, and divide by the second term, which is sine theta. So either way, our common ratio turns out to be sine theta. Now, here's the thing. Sine theta, as we know, if you know your graphs well, which reminds me I need to make a video on quadratic graphs also. Sorry, not quadratic, trigonometric graphs. Is basically a curve that goes from minus 1 to 1. Okay, doesn't go beyond 1, doesn't go less than minus 1. Although it is equal to 1 and minus 1, but for this particular range of theta, it's not going to be equal to either of that. Let me show you why. Now, sine 90 or sine pi by 2 is basically equal to 1. So we have 1 point. And at 0, it's 0. And sine of minus 90 is going to be equal to minus 1. So it's going to be somewhere over here. So if I were to draw a curve, if you know your sine, cos, tan curves well, you know that this is what this is going to look like. This is theta, and this is what the common ratio is. Now, if you can see, the question says that theta is not equal to pi by 2. It's pi by 2. It's less than pi by 2, and it's greater than minus pi by 2. They're not equal. So since theta is not equal to minus pi by 2 or pi by 2, our common ratio will always be between minus 1 and 1. Okay, and our common ratio over here is sine theta. So you'll write sine theta is always between minus 1 and 1 for theta greater than minus pi by 2 or less than pi by 2. Therefore, sum to infinity exists. And there you go. This brings me to the end of the question and also to the end of this video. I hope you guys have understood this, and again, I hope you guys are practicing. You probably have an exam on Friday for those of you who are appearing in the October-November exams. So yeah, best of luck to you guys once again. I'll try and post a couple of more videos on trigonometric graphs, and maybe if time allows, linear law also. So yeah, I'll see you guys in the next video. Until then, take care. Bye-bye.